In the Quantum Technology and Innovation track, and I'm thrilled to introduce you to Daniel Verdu. Daniel is a data scientist engineer who specialized in image analysis using artificial intelligence. In 2015, he was selected as CERN summer student to join the ALICE detector control system group. In 2016, he joined the other students to create the Spanish HyperloopUPV team and participated in the SpaceX Hyperloop competition. The goal was to design a scaled, real prototype of a futuristic transportation system to be tested at SpaceX facilities in Los Angeles. Daniel joined the project as technical director, leading a team of 30 students. The project was awarded as the world's top 8 best prototype, with more than 300 universities participating from around the world. In 2017, Daniel began to learn about artificial intelligence. He focused mainly on the computer vision area, and in 2020, he won the Computer Vision Spanish AI Hackathon with this solution for the Image Super Resolution Challenge. We have a 20-minute talk followed by about 10-minute Q&A. Thank you, Daniel. We look forward to hearing your talk.
Hello, everyone. Thanks for this perfect introduction to me. I'm very excited to be here again, 6 years later. I've been in 2015 at CERN as summer student, and today I will try to explain the path I followed in the last years and why I've moved from developing control systems for robotics and automation processes to the design of new electric transportation systems, and finally to the implementation of artificial intelligence solutions on industry. All the decisions taken in this time have had the same purposes: being places where I could work and research in cutting-edge technologies and innovative projects that could have a positive return in people's life. As a child, I was a very curious kid, and my mind was plenty of questions that I had to answer in order to understand why the things were like that and not otherwise. This curiosity as a child was the seed of my passion for research, and it has served as a motivation for working hard in order to obtain the opportunity to be in places where biggest discoveries were taking place. So returning, I think it cannot work. Okay, perfect. Returning to my technical background, I have had a briefing of it here. I did a bachelor's degree in industrial engineering in 2010, because it was the most generalistic applied career I could study. For me, I prefer to know the basis of different fields instead of being a specialist in one of these. So I finished my degree in 2014, being awarded by my bachelor thesis as the best project in control engineering for designing and implementing control flight algorithms for drones using low-cost sensors. After my bachelor's, I continued my studies at the same university, and in 2015, I was selected as CERN summer student. For me, it was like a dream come true to be part of one of the best, largest scientific experiments that have existed in our history. And it was also the reward for all the hard work I put during my studies. In 2016, I returned to Spain and I joined the Hyperloop UPV project as technical director due to my generalistic technical profile. And our goal was to contribute in the development of a disruptive new transportation system. And finally, in 2018, I moved to a completely different field, that it was the artificial intelligence. I started to learn about artificial intelligence on my own because I was amazed by the first AI applications that were appearing and the enormous positive impact that AI could have on people's life. So during the last years, I have developed my career as artificial intelligence engineer focused on image analysis problems. And on March of 2021, I won the national hackathon, and it was the recognition for all the work I've done during years for developing myself in a new different field from I was doing. Yep. I think, can you show the next slide, please? Yeah. So now I want to talk about my work at CERN. What I did at CERN in 2015, I was selected for being part of the detector control system department of the ALICE experiment under the supervision of Professor Ombretta Pinazza. My goal was to develop a software that should be able to collect all the data coming from different systems that forms the ALICE experiment, and to categorize, analyze, monitor, and publish all this data to internet. So in this process, I had to develop all the software to aggregate all the information in XML files and publish as RSS feeds. So the software has to be able to publish information in regular intervals or when a predefined condition was satisfied. Can you show the next slide, please? Yep. So I want to talk also about not only about what I did at CERN, also to what I got from CERN. For me, looking backward, for me, CERN summer student was a life experience that changed my life completely and my way of thinking. Most of the people here have spent several years at CERN acquiring a lot of different technical skills. But however, I've been only 3 months there, but in the same way I learned other valuable things. Firstly, before I participated in the summer student program, I had never lived outside of Spain nor had any professional experience. So for me, CERN, some experience has formed me as a professional and made me grow as a person. At CERN, I live in a multicultural atmosphere where I meet people from different parts of the world that enrich my experience and awakened my interest in traveling and discovering new cultures. Secondly, I had the opportunity to work in high-performance teams from which I learned different work methodologies that I use nowadays. Thirdly, at CERN I met different researchers from which I learned their know-how and their passion, which make me a greater professional and researcher. And finally, this experience opened my eyes about the impact that research can have in our society. Certainly, it has inspired me to drive my work towards research so that it can have a positive return in society. For all of that, I think that CERN Summer Student Program is a once-in-a-lifetime opportunity, and I'm so glad I didn't miss it. And in 2000, after finishing at CERN, I was a bit overwhelmed about the next step to take in my professional career, and I decided to continue my studies at Leuven in Belgium. At that university, I had the opportunity to attend the lectures of an advisor to the European Committee on climate change policies, which made me aware of topics such as human carbon footprint and sustainability. So in 2016, motivated to participate in innovative projects and aware of these issues, I returned to Spain and I joined other students to create the HyperloopUPV project as technical director. But what is Hyperloop? Hyperloop is a concept of a disruptive, high-speed and sustainable electric transportation system for both passenger and freight transport. It has 3 major components: a tube, a vehicle, and a terminal. And this transport concept has several benefits over conventional high-speed railways. First of all, it can reach higher speed. How? The vehicle travels inside a sealed tube with lower pressure. The air is extracted from the tube with pumps distributed along the tube in order to reduce the vehicle's air friction. As for putting numbers into this, the idea is to have 100 times less pressure than atmosphere. Besides, the vehicle is able to levitate from the ground while moving to reduce ground friction. So if we have reduced air friction of the vehicle and also we have reduced ground friction, Hyperloop could potentially move at airline speeds around 1,000 kilometers per hour. Secondly, a Hyperloop is a safer transport because it travels inside a controlled environment. As the vehicle moves inside a closed tube, all the influence of weather events like snow or thunderstorm is reduced. Besides, the closed tube makes that the vehicle is free of collisions during its performance, and also it prevents derailment. Thirdly, Hyperloop is proposed to be electric propelled, and it will have onboard batteries that will power the vehicle during the trip. Its batteries can be charged or replaced at the end of the trip, reducing the fossil fuel dependency of conventional railways. Additionally, the energy needed to pump out the air from the tube can be obtained from solar panels or wind turbines disposed along the tube, reducing human carbon also. The Hyperloop concept has its roots in 1800, and there have been many different technical proposals during history, but in 2013 it became a current issue again because Elon Musk published a paper called Hyperloop Alpha, when he argued how to connect San Francisco and Los Angeles with a new transportation system called Hyperloop. He argued that Hyperloop would be safer, cheaper, and faster than the high-speed railway alternative. With this transport, the 560 kilometers of distance between both cities could be covered in 35 minutes. Besides, he published all the calculations made by his team and all the technical proposals for the different systems, both in the vehicle and infrastructure, in order to open the development to all the community. Some of the Hyperloop Alpha technical proposals were an axial compressor placed at the nose of the vehicle for transferring high-pressure air from the front to the rear. For propulsion, he said electric linear induction motors, where the rotor can be a simple aluminum blade. Regarding to levitation, he proposed air cushion to levitate the vehicle between 0.5 and 1.3 millimeters from the ground. And finally, he proposed solar panels on the tube as the main energy source. So, in 2016, Elon Musk organized a competition between universities around the world to build subscale prototypes in order to demonstrate technical feasibility of several aspects of the Hyperloop concept. In words of Elon Musk, despite they were not developing a commercial Hyperloop, they were interested in helping to accelerate the development of a functional Hyperloop prototype. The competition took place at the SpaceX facilities in Los Angeles, and for the competition there was only one judgment criterion: reaching maximum speed with successful deceleration. I participated in this competition with the Spanish team, HyperloopUPV, as technical director, leading a group of 30 students. In the image of the right, you can see our prototype that finally compete there. I have had some of the test track specifications we had to deal with. It was a tube that you can see also in the images of 1.68 kilometers length. As a result of the competition, our prototype was ranked as the top 8 best prototype of the competition among more than 300 different proposals from around the world. So, in 2017, I finished my participation in the Hyperloop UPV project, and I took some time off to think about which was the next step to take in my professional career. In 2018, I joined a Spanish company dedicated to the automation of industrial processes as computer vision engineer. My work was to integrate traditional vision solutions for quality inspection tasks. But after a little time, I started to hear how artificial intelligence solutions were emerging as an alternative for solving image analysis problems, improving traditional solutions. So, motivated by curiosity, I decided to learn what I could in my free time about AI systems focused on their use in image analysis problems. In my case, I did several online courses taught by prestigious researchers in the field just for free, thanks to the fact that nowadays all the knowledge is freely available on internet. And this is something for which we have to thank CERN as well. Firstly, for its contribution to the internet development, of course, and secondly, for its transfer knowledge policy, which has influenced the scientific community in a movement to open and share the science and the knowledge to the society. Returning to the AI topic, thanks to AI solutions, some of the visual inspection problems that were out of the scope for traditional vision systems have been solved, making a true impact in different applications and industry. Moreover, the use of AI on industry has improved the manufacturing efficiencies and has released the human force from performing repetitive and dangerous tasks, increasing their happiness and their job satisfaction. I have had some of the main AI solutions that are being used on industry for visual inspection. First of them is the example of an object detection system which detects if there is a clip or not. And in affirmative case, where it is and if it's well positioned, that you can see in green or not. The second example is a system called Optical Character Recognition for text recognition, because AI systems are good interpreting handwritten texts or industrial text with shadows and poor lighting conditions without the help of any template. The system gives a score per character and per word, avoiding errors due to an error in a single character. And the third example is an example of an anomaly detection problem where the system is able to detect which component is different from the normal production. This technique is used when you are not able to reproduce all the failure cases or they are unknown. So besides the industrial applications, there are other interesting fields that I want to highlight where the use of AI solutions could have a major positive impact. So first of all is the healthcare, because with better data management and monitoring capabilities than humans, AI systems can be valuable tools for improving patient care, early diagnosis, and for accelerating the development of personalized treatments. The use of these tools can allow the healthcare professional to spend more time with patients and to reduce operational costs. In the first picture, it is shown how AI could be used to the early detection of breast cancer, which can make a difference between saving a life or not. The second of the images is an example of a project I work on, which consists in the detection of malaria infected cells to accelerate the malaria diagnosis. Actually, the protocol is to count manually how many red blood cells contain the parasite over 5,000 cells, which is a very slow process. So if we can use AI to accelerate, to boost this process, I think it can have a huge impact. Another example of where AI can have a huge impact is in the development of autonomous transportation, reducing the number of road deaths, reducing traffic congestion, and allowing to spend our time in different tasks. In the same way, AI is being used to develop a smart tractor, which can be used in agriculture to do the job without the human intervention. Another example where AI can have a huge impact is in the photography and image processing. Most of the actual mobile phones that we use AI to identify objects and scenes, to adjust the camera parameters like brightness or contrast, and to improve night mode photos. AI can be also used for upscaling image resolution while maintaining the realism. At the right, you can see the output of the AI model I used in a national hackathon I won in 2021. The challenge consisted of upscaling and painting pictures to images with 4 times more resolution than the low resolution original version. Another interesting applications could be image generation, data processing, also for helping people with disabilities, and there are a lot of them. And while the original goal of AI is to benefit humanity. There is also other applications that is good negative impact society, as deepfake, where a person in an existing image or video is replaced with someone else's likeness, intelligent military weapons, or applications for the control of society. As you have seen, AI have infinite possibilities in so many different fields, and depends on us to use it for good purposes or not. At the moment, I'm still working on AI because it's huge potential for benefiting the people. Because at CERN, during my experience as summer student, I became aware of how important research could be for our society and for people, and I want to contribute and to put my effort to achieve this goal. So I would like to thank CERN and to all of you very much for the opportunity of telling you my story. And I would be more than pleased to answer any question you could have, so please do not hesitate to ask me.
Thanks, Daniel, for the presentation. It's incredible to see your journey over from summer student to Hyperloop and into AI. We've got a bunch of questions coming, and I'll try to get through those questions as much as possible in the next 10 minutes. The first question was, are you still in touch with most of the cohort from your summer student program that you were at CERN with?
No, not at all. This is something important about the CERN alumni network initiatives. Sorry, I think I have problems with the audio. I have echo in my voice. Yeah.
How about now?
So,
is it okay?
Yeah, no, not solved yet. So the point is, I'm really open to contribute to initiatives for the CERN alumni network, because I want to be more connected with people with similar interests like me, like the CERN alumni. For example, during the CERN second collision event, I had the opportunity yesterday to talk with another CERN students, not from my year, from other years, and also people with similar interests, and to share my doubts with others about the next step to take in your career, on how did you deal with different problems, and about how it was your experience. So I think all of us should put our effort to create a really strong network between us, because I think it will enrich our experience and all of us.
Thank you. Totally agree. For me, alumni represents that, right? So sum of all the different parts is bigger than the whole thing. So next question was, construction and maintenance costs for the Hyperloop, could they reduce the overall economic advantages of the Hyperloop?
I think that at this moment also the costs are very high, because the technology is not mature at all, but I think that the advantages are stronger than the disadvantage that they are at this moment. So, for example, one of the ideas that are on the table at this moment is to put all the technology on board of the vehicle to reduce the cost of the infrastructure. And regarding to the infrastructure, now it's expensive, but if we think about in the cost of high-speed railways like the maglev, could be similar at this moment. So as much as the technology evolves and develops, I think the cost will reduce, and also the advantage are still there.
Right. So to follow up on the question is, you are putting the infrastructure cost into the vehicle rather than putting, large electric lines that will have to feed the entire track. So track per cost track is less with Hyperloop.
Yeah. For example, for the only energy that you need for the infrastructure is for the pumps to remove the earth from inside of the tube, and it can be fed up by solar panels or wind turbines. So we can reduce, we don't need electric infrastructure, of course, and all the motor, the batteries would be on board of the vehicle. So we can reduce the infrastructure cost.
Oh, thanks, man. So, another question is, what's the framework that you use to find a project or a real-life problem when you're working with AI?
I work on industry, so for me, most of the challenge is to understand the process of our clients, to understand how the data is produced, their goals, what they want to do, and my role is to give them the information of what things they can do with the help of AI. So there is we can say a new field of interest, a new theoretical movement that you have put more effort in your, it's called data-centric, and it means that you have to put more effort in how do you obtain your data, how well is your data, how clean it is, instead of putting the effort in the model, in the architecture selection. So at the end, with good data, the rule of thumb for us is if your eyes can see it, I could build an AI system to detect.
One more question is on reliability and traceability of AI systems, the black box that you have to look at, how the AI system actually works. Do you look at it from a perspective of how do you look at whether the AI systems are, the results are traceable? Do you put that in the design process?
Yeah, there is an actual problem about AI systems that, for example, in most of the cases, they are black boxes that our clients don't understand. And there were different alternatives and different initiatives to put a bit of light in what the AI systems are doing. Recently, there appeared a new architecture called transformers that are being used also for image analysis, and one of the amazing results of the transformers used for visual analysis, it was that some cells, let's say, learn to recognize some different patterns, like the faces, like places. So you can interpret with transformer a bit more about which cells are being activated depending on the image and what they are learning. So the research is putting effort in understanding a bit more what is happening inside of the AI systems.
Thank you, Daniel. We wish you the very best for your future career, and thanks for taking time to participate and share your experience. Thanks. Good luck.
Thank you very much.